Alright, since I know I have everyone's attention right now, no one has their ear warmers on. It's not that cold in here. Your earbuds are away. Yes, that guy with the hand.
I need a
You need what?
yeah.
A stencil? Pencil. How have you been doing the homework all this time? Oh, he stole it? He stole it?
No,
Alright.
whatever.
Alright.
Thank
Don't you whatever, bro me.
I
Don't you whatever, bro.
I appreciate you, Pancho.
Okay, you're welcome, bro. Alright, class.
Yes.
That was kind of weak.
You're weak.
Your mom's. Anyway, so for those people paying attention, since this is a new set of notes, this would be 29 today. 29, right? Because 27 was on the other day, 12/3, right? Yes? Hopefully? Okay, good. So, 29 for today, this is normal distribution. This right here, it appears more complicated than it actually is. So we're going to go through and we're going to talk about statistics for normal distribution. A normal distribution, called a bell curve or Gaussian distribution, whatever that is. All right, so yeah, some guy that was gassy decided to come up with it. Normal distribution is bell-shaped, so symmetric about a vertical line through its center. Mean, median, mode are all equal and located at the center of the distribution. So, what they're saying is this referred to as the bell curve. That most of the data items are going to happen right there in the middle. Okay? Normal distribution. Shape of the normal distribution depends on the mean and standard deviation. Mean, what was the mean again? Do you guys remember? What was it? Not Mr. Stiles? Yes, because Mr. Stiles is not the mean. He is far above the average. Right? See what I did there? See what I did there? So Dr. Stiles is above the average? Okay, good. All right, and I know P. Diddy doesn't have earbuds in right now either, does he? No. Okay, because he wouldn't do that. So the shape of the normal distribution depends on the mean and the standard deviation. These three graphs have the same mean but different standard deviations. As the standard deviation increases, the distribution becomes more spread out, but retains its symmetric bell curve. Now, standard deviation. It's referring to how far it is away from the mean. To deviate means to go away from. So a standard deviation is in equal parts going away from the mean. So in the standard deviation rule, see this right here? This is going to be key for you. Every time that we're going to talk about this, we're going to refer to this right here. The 68, 95, 99.7. Doctor?
Quick question. Where is the mean going to be located when you look at a bell curve? Where's the mean going to be located when you look at a in the middle? Exactly. So make sure y'all remember that.
That's super important. Okay? It's always going to be right there in the middle. So, 68, 95, 99.7. That means in this curve that 68% of all data items are going to lie right here in the middle. Okay, 60%, 68% is all going to be in there, right? Yeah. And each one of these is referred to as different parts. So if I do a +1, that would only be half of this. That would be this going this way. What do you think that percentage if I only had +1? What percentage would be +1 standard deviation? If the whole thing is 68, what do you think +1 is? 34, right? Why would it be 34? It's half of 68. So is that important to write down? Maybe. Okay. Should you be sleeping on your desk right now? No. Okay. Someone had their butt on that desk right before you walked in here, just so you know. Okay. Someone was sitting on that desk. Okay. So, right here, this is going to be 34%. For this one's going to be 34%. This is going to be key. And as we go through here, I'm going to give you percentages for each one of these individually to help you out. So approximately 95% of the data items fall within 2 standard deviations. So 95%, so that means that from here, all that is going to be 2 standard deviations. So that means all data items, 95% of all data points is going to fall within that. So in that category, if this class was a bell curve on grades, okay, whatever that average grade is, we would break that down, and 95% of all the students in this class would be in between, 30% and 90%. That's what that means. So, given that information, the other side, so below 30% and above 90%, would be another 5%, wouldn't it?
Yeah.
So that would be another 5%. Or if we break it down again to the plus 3, that's 99.7% of all data points. So is it possible for someone in here to have a grade that is outside of that? Yeah, there is. Because it's 99.7% of all the grades are within that data point. Is it possible that someone has an absolute 0? Yeah. That would most likely be outside of the 99.7. Okay, that is called an outlier. That's one of those far-reaching things that it's really hard to get one of those things. It's like playing the video games and you're trying to get like a rare drop or something like that, like a super rare drop. Yeah, whatever it is. Okay, so whatever games you play or something like that. So yeah, that's like trying to get that hologram Pikachu on your Pokemon Go. Okay, there is one. I heard about it. I did. Okay, it's legendary. Really? Really? Okay. So approximately 99.7 of all the data items fall within 3 standard deviations. Okay. Male adult heights in North America are approximately normally distributed. Ooh, normal distribution. So, whenever we say normal distribution, what should you think of when we say normal distribution? Oh, no. They're talking about the bell curve. Every time you hear normal distributed, you think of bell curve. Normal distribution refers to that bell curve where we got the 68, the 95, the 99.7. Every time we have that, you're going to have to be like, oh, okay. So now, if the mean is 70 inches, so the mean is 70, so mean goes right in the middle, right? Standard deviation is 4 inches. So what did I say a deviation does? Right? Moves away from the what? Right? Very good. So it's going to it's moving away from the mean. So every deviation is how far away? 4 inches away. So if I go plus 1 deviation, so plus 1 over here, that would be 74. Very good. So that would be 74. All right, what if I go down over here? And if I go minus 1? It would be what? 66. Very good. Good job. So you guys are getting this now. All right, so now, again, so this one right here is asking for, find the height that is 2 standard deviations above the mean. So that means I'm going to go plus, right? Not the minuses, right? Okay, so now let's see what plus 2 is going to look like. Plus 2 is going to be what value?
Oh, 78.
78. Very good. And that's the answer I'm actually looking for here. I'm looking for the plus 2 standard deviations above the mean. Very good. But let's just keep going with this since we are filling this in. So what do you think my minus 2 would be?
64.
60 what?
62.
62. Because I have to subtract, right? I'm subtracting 4 every time. Okay? And let's, while we're here, let's go, what would my plus 3 be? 80 what? 82. And my minus 3? 58. Very good. Again, it sounds more complicated than it actually was, right? So it's almost like, you know, it's super easy, but you had to make sure you're paying attention. It's almost like putting earbuds away and thinking that I can't see it. Thank you. So this one, the answer is going to be 78 inches. Very good. Okay. Use distribution of the male height in the figure to find percentage of men North America heights between, oh, hey, look. Now, between 66 and 74. Now we're going through 66 and 74. So in between here and here, what percentage is going to be all of that? 66 and 74. 68%. Very good. So in between those, so 68% of all adult men in North America are going to be within that range. Does that make sense? Anyone got questions over that? Super easy, right? Okay. We could go a little bit crazier on that one. So we're going to do this, and on this page is blank. We're going to fill in everything. All right. So this is going to be your cheat sheet for everything here. Now let's see if you paid attention a moment ago. We said that in between -1 and +1 was what percent? 68%, right? And then, but what is just from the mean to the +1? What percentage is that? From the mean to +1? 34. So this side is 34%. Okay. So what do you think the left side's going to be? 34% also. Hey, move a desk already. We still got like 20 minutes of class. So 34, 34. Okay, so now let's keep going out. So this was all the 68% from here to here, right?
Yeah.
The next one went out to, yeah, it went out to 95, didn't it? So I'm going to do a little bit of math. Let's go 95 minus 68. What do we get?
27.
27. So it's going to be 27. So there is going to be 27% added to my 68, right? But for each item, or every plus one or the minus one, 27 divided by 2. So just this right side over here, which is from plus 1 to plus 2, I'm going to add how much? 13.5%. All right, what about that left side then? 13.5% also. So we're filling in because some of the questions they're going to ask you, they're going to be like super weird questions. They're going to be like, all right, from the mean to plus 2, what percent would be from the mean to plus 2? You're like, okay, from the mean here to plus 2, I would add those two together, wouldn't I? Yeah. So that's how I would do that. Okay, so now let's look at the next part. I got to get into the plus 3 range. Isn't that plus 3 range 99.7? Okay, so I'm going to subtract all that's in between, which was the 95, wasn't it? So it's going to be 0.7. What else we got there? 0.7. So there's 4.7% added to that. Now I'm going to take that 4.7 and do what? Because I got to get both sides. Divided by 2. Very good. Yes, divided by 2. So take that, divided by 2. Which is going to give me 2.35%. So this one right here is an extra 2. And right here also now when it comes to actually getting to your homework, you're going to see it's going to ask for certain parts of this. And you're going to have to just say, okay, what percentage between the plus 1 and plus 2? What in between plus 1 and plus 2 would just be 13.5%, right? That's it. This is going to be your answer key for most of the questions that you're going to have that are going to be like that. Yeah, I'm going to get there. Okay, so for all this right here, and again, doctor wants to go with that last one. So we're going to go for the last little bit, which is outside that, which is my 100% minus my 97 or 99.7, which is going to be 0.3. 0.3 divided by 2 is going to be 0.15%. So 0.15% there, and also a there, 0.15% there. There we go. Let me draw this out a little bit longer. There we go. Arturo, did I lose you there? You zone out? A little bit. It's all right, though. All right, now that we got all this, we're going to do some z-scores. This is actually super easy. It's basic math. Basic math. Yeah, computating and finding z-scores sucks. But what we're going to do with it right now is just finding a z-score. Data item minus the mean divided by standard deviation. It sounds crazy, right? Okay, the mean weight of a newborn infant is 7 pounds, and the standard deviation is 0.8. The weight of a newborn infant is normally distributed, right? Normal distribution. Find the z-score for a weight of 9 pounds. Okay, so weight of 9 pounds. So the z-score, so z of 9 is going to be equal to, my formula said, my data item. What was my data item? Okay, it's going to be 9, right? 9 pounds. Minus mean. What was the mean? 7 pounds. Standard deviation, 0.8. So that's going to give me 2 divided by 0.8. Say what? When you did the math. All right. What'd you get? 2.5? Point. Did you divide by 0.8?
Oh, yeah, I didn't do that.
There you go.
I was like, well, that
Okay. So the z-score of 9 is going to give me 2.5. So let's go back to the wording of what this means. If your baby was 9 pounds, okay, that kid would be 2.5. It's a positive number, right?
Yeah.
Standard deviations, right, above normal. Normal distribution would be, you know, if you have a 7-pound baby, that would be average, right? But you had a big baby. Big baby.
Hey, wanna know who was a big baby? I was 12 pounds.
My nephew was 14.
That's what I
Yeah, that's crazy, right? Yeah, crazy. Anyway, so, yeah, 2.5 standard deviations. Is that easy? Basic math again on this one. Even though it sounds crazy, we're just doing basic math. And guess what? I'm going to leave off there. I'm going to let you guys make sure you all like, share, and subscribe. Hit that notification button, support my channel, and start working on your homework.